All right, so now that we've seen the basics of cosecant, let's look to see how we're going to do a transformation on cosecant. So I have an equation here, f of x equals -3 cosecant of pi over 2 times theta minus 1 plus 2. Now, if you notice, this is our general form, a f of b times x minus c plus d. So let's do this. The first thing I want to do is I'm going to recognize that there is a direct connection between the graph of cosecant and the graph of sine. So if I can figure out the graph of sine, I can use that to help me graph cosecant. So that's what I'm going to do. I'm going to basically change this into the graph of sine it's related to. So the only thing that really changes is -3. I'm going to change cosecant to sine, and I'm going to keep everything else the same. I'm going to graph this. If I can graph this, I can use it to construct my cosecant graph. So here we go. So what I'm going to do is do my point-to-point mapping like we've been doing in the past. I'm going to do my x and my y. These come from my parent function. And I'm going to pick 0, pi over 2, pi, 3 pi over 2, and 2 pi. So these are points just straight off the parent function. All I do is I put them into the parent function. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is once again 0. You would know that once you have your unit circle memorized. All right, now from here, I set up my mapping. We need to remember that my x mapping is always opposite of what I see. So I see pi over 2 times all of this. So I'm still going to use multiplication, but I'm going to multiply by the reciprocal. So instead of doing pi over 2, we're going to do 2 over pi. So I have 2 over pi x, and instead of -1, I'm going to do +1. Now I'm going to throw these numbers in and get a new value. So if I put my 0 in here, I'm going to get a 1, because 0 times this plus 1 is just 1. If I put pi over 2 in this, I'm going to get 2. If I put pi into this, I'm going to get 3. If I put 3 pi over 2 on this, I am going to get 4. And if I put 2 pi into this, I'm going to get 5. Yes, I was nice to myself and set this up, or is nice and pretty. All right, now we need to do my y mapping. Well, my y mapping is what's on the outside. So think of this whole thing as your y, like f of x, like your f of this. This whole thing is f of x, which is a y value. It becomes -3y plus 2. Take my y values, plug them in. 0 times -3 is 0, plus 2 gives me a 2, -1, 2, 5, and 2. All right, perfect. So now I have points. All I have to do is go in and graph 1, 2, 2, -1, 3, 2. And I have my graph of sine, not cosecant, because we're going to use that to build my graph. So let's do some graphing. So I have, let's call this 1, 2, 3, 4, 5. All right. So we're going to go 1, let's see, 1, 2, 3, 4. Let's extend this up. 5 and -1, and that should be good. So we're going to go 1, 2. I'm going to go 2, -1. We're going to go 3, 2. We're going to go 4 to 5. And we're going to 5, 2. All right. And then here is my rough graph that I'm going to use to construct my cosecant. Now, one of the biggest mistakes I see, because the original graph was on the x-axis, you're going to want to say there's a vertical asymptote here and here on the x-axis. That's not the case. What's really more important is, where is the midline of this graph? That midline is going to tell you where your asymptotes are. So my midline is right here. The way you can find that is just look at your amplitude, which is 3. The absolute value of -3 is 3, and you're going to count. Or you can just look and see, okay, well, what number is repeating at my midline? All my zeros became 2s. So that is the midline. That is where my asymptotes are. So everywhere on this midline, I'm drawing an asymptote. Everywhere on this, I'm drawing an asymptote on that midline. And then wherever I have a minimum, that's going to go towards negative infinity. Wherever there's a maximum, it's going to go towards infinity. And that's all I would be looking for if I asked you to graph it just one period. I don't need you to extend it out, but you could if you wanted to. If you notice there is exactly one tick in between. So I could say there's another tick here. Here's my tick. There's another asymptote here. Will it repeat? So this one would have to be right up top like this. And you just keep going forward and backwards, however you want to do it. Once you recognize one period, the rest of it, it's just a mirror image of it. So not terribly bad, but you've got to be able to recognize the connection between cosecant and sine. You've got to be able to do the transformations of sine and understand that your vertical asymptotes are coming from your midline, not the x-intercepts. Wherever your zeros are, whatever you're going to get the same number, that's going to be your midline, and that's where you're going to get your vertical asymptotes. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.